I figured it was best to start this video here, answering quantum tunneling. It was 2006, 2012 circa, where I asked myself, I need a superconductive wire, but that wire needs to be hollow. This answers what's going on in standard copper wire, standard copper wire that we're making superconductive. What you're looking at is my nanotubes, crystalline superconductive structures in tungsten. They bored and gave superconductive tunneling in tungsten. So let's have a look. Okay, let me get this set the best I can here. And we're going to go backward. Give me a moment. I'm just coming back up the tungsten. So we can look at the original milled and drawn tungsten and the crystalline structure. Right there. Okay. It takes a little bit of practice with a density microscope, but that's to be expected. You notice the grain. We go up the tungsten even further, and it's all copacetic. Now we're going towards the tip, but look at the consistency start to change. The closer we get to the tip, you see the change in the gold color. Now we're going to come to the first temperature band. You see that? Wait till I load my biometals page. It will literally blow your mind. You notice the grain is changing, and now it's getting more dense. So I have to go out to focus. The peak is closer, and I have to go up to focus. That means it's more dense in a density microscope, refractive light microscope. You see the colors? Let's go back. That's a little psychedelic. But the color of purple indicates the color of gold vape. Now look, we're toward the tip of the tungsten electrode. You see the purple? But look at the grain structure now. It's enhanced from the pressure of the graphene. Now look at the grain structure. You see that? Digestion. Now we come towards the tip, where I've brought the tungsten electrode to a point. Look at that. I can pretty much tell you that is definitely a U. Now I'll try to adjust the density. Let's look around here a little bit, see what else we see. Now look at the very tip. You see how dense it is? In tungsten. I've seen this before, but not in this particular process. Now look at the, I have to only can go a little bit at a time, and the density is changed. So much so that the microscope view, I can only go a little bit, and then I have to continue to go down. And now we're back at the tip again. I wasn't sure how long I was going to spend on this video, so I was hoping to get your attention right in the beginning, right out of the tip of the electrode, in a tremendous amount of potential, proving the biosphere understanding that our mantle is clearly alive with biological life, because those worms are the worms from hell, nicknamed, that give us our gold. But they also digest other digestive metals, proving all metals come from bacteria. But once these guys got to the tip, as you saw the video of me arcing the nuts I'm sorry. But this goes way back between Russ Grease and I from RWG Research, who's got bigger nuts. So I first thing I decided to spark. I'm sorry, I cannot hold the camera still. The first thing I decided to spark with the torch were a pair of nuts. Ladies, I'm sorry, it's a guy thing. Okay, back to some serious science here. Now I'm compelling you to watch the ARC video of the first fire. Sometimes I will stop the entire facility just to observe something different. I am not self-proclaimed. I've been clearly noted that something that I have very much skill in is the power of observation and what that means. It's when a lot of people in research and science look over. They think, oh, because the arc stopped, well, that must have been a failure. No, actually, it was not. I stopped because there was a change. It was not normal. I could have ground the tip and started again, but that would have been futile. I'm sure for a fact these will grow out again, but this is just a nice cold open first representation of what this energy does. I'm going to turn up the potential so I can actually weld the nuts together, but this was very interesting and I hope you thought so too. Thank you and have a good day.